tardes a todos.
Good afternoon. I'm Ignacio Piantanida. I work at 10 Pines developing software. For a year and a half, I've been working with RubyMotion, the tool I'm here to introduce you to, for a startup known as Pay Friends. For yes, I think I'm here to tell you why it's a good tool, why Rubists should be using it. A sort of personal survey. Do you know what RubyMotion is, or what it aims at? That's many of you. Have you ever used RubyMotion? I was expecting less. That's quite good. If you don't know, RubyMotion is an implementation of almost Ruby 1.9.3. It's built on Object-C runtime and compiling through LLVM through native code. With RubyMotion, we'll create iOS and Mac applications in a native fashion. RubyMotion was a fork out of Mac Ruby project that started within Apple, a project to build Mac applications on Ruby. But at a given time, Apple decided to discontinue the product, and Lawrence Sansonetti, the lead within Apple for that project, came out of the company and created his own company, HipByte. It's a very tiny company, just 5 developers. And it never accepted any foreign and external investment, so RubyMotion is a commercial product. The license costs $199 a year to maintain the updates, new versions. It doesn't have a field trial to test the product. You just have to buy the license ahead of time, but their policy is that if you don't like the product, in 30 days you get a refund. You're paying for a closed source compiler that turns Ruby code into native code. RubyMotion has another leg, which is open source, which is part of the building process. It's a GitHub process. You can submit pull requests, look for issues, improve performance, and that part is open source. Now, why would anyone like to use a tool which is not native or the one supported by Apple to produce its applications? This is a minor example of what a class is. This is a class method for a builder, and here you can already see Object-C code 3 times longer than what you need for Ruby, and the Object-C code has to be separated in 2 files because interfaces are on one file and implementations in another file. So the Object-C code requires lots of typing. There are files of Object-C that have more than 600 lines of code. The last one, Object-C, launched by Apple, things improved, but Swift is still a typed kind of language based on syntaxes with a long manual, so there's no reason why I should try to convince you why Ruby is better than that kind of a language. Why did I say almost Ruby 1.9.3? Because it keeps the good part of Ruby, the modules, the mixins, open classes, even native framework classes can be reopened, and we can redefine methods. We can use meta programming, message sending, instant CVAL, and that's what's unique about Ruby. The big difference is that RubyMotion is statically compiled. There are no requires, there's no interpreter telling me that parses and compiles the code. It detects all files that depend on it, it estimates dependencies in between files, and it creates a binary file. Everything outside the binary at the time of compiling is unknown at runtime. Because there is no interpreter in execution time, we cannot use the deval method. You cannot evaluate a string, no eval. And this is because Apple forbids specifically codes to run like that. There's no binding method because of performance. This would allow for optimization of local variables, and due to performance we cannot there's no fixed non-method overwriting, so certain performance improvements can be done. Another big difference, which it was harder for me to adapt to, is that there's no garbage collector because of performance issues as well. What we use as memory management is like in Object-C. We have an ARC, automatic reference counting, and each object has a counter, and every time that a variable is assigned to that object, counter increases 1. Every time you disassign, the counter goes down. Once it reaches to 0, that object can be released from memory. But you need to be very careful with this, because if you have an A object pointing to object B and B pointing to A, you create a cycle with two counters pointing to 1, and that's memory that is looped and no way to recover it. This happens a lot when you create blocks, and with Ruby you create blocks all the time because a block is always binded to the whole context around it. So the community discovered that, oh my god, blocks are holding my objects, and all libraries created patches to solve this problem. On the other hand, Objective-C, it has its own named parameters. So RubyMotion had to implement named parameters that we already have in Ruby 2, because the dismiss view controller animation completion is not the same as the one at the bottom. So we had to implement this new syntaxes when you have an object as the last parameter. It also adds some sugar to syntax. In Objective-C they used set font and other set something. In RubyMotion they are written as equal to and the same as is something. In RubyMotion can be written as something question mark, and so the code is more robust, if we may. Another important characteristics, and one of the main advantages over its Objective-C competitors, is that RubyMotion doesn't have a bridge. No bridge means that you don't have to turn objects from the Ruby world to the native world. For example, in the case with some frameworks on JavaScript, which improves a lot performance. There is no performance penalty for using RubyMotion. Another advantage, because there is no bridge, you don't depend on just using what the bridge shows or implements. RubyMotion overcame this by building Ruby on the runtime where Objective-C is written. This means that RubyMotion and Objective-C are equal and that they can coexist seamlessly. Objective-C classes can be used as Ruby classes and methods and so on and so forth. For that, we've built the basic classes of Ruby on they were built on the Objective-C classes. Object is NS object, string NS mutable string, hash mutable dictionary. So any API of Objective-C that expects one thing as a parameter can also receive a string of Ruby and will continue to work perfectly fine. Another difference, and this is for our advantage, at least for me, RubyMotion is based on console flow. All actions are carried out through rake tasks. We have the rake simulator, rake device to send the application to a device, rake archive to create an API file to the App Store. We can create our own rake tasks that call on existing rake activities. In the project where I work, we have rake deploy. It runs OTs and uploads it to the analytics server and to the beta server, everything with a command on the console. Now, what happens with Xcode? Everything that we developed in Objective-C in an original fashion goes around it. Project configuration, screen design, everything comes from here. RubyMotion is Ruby, and therefore we can use any editor, Sublime, others if you're more hardcore. RubyMine is integrated with RubyMotion, so you have syntax highlighting or auto-completion of Objective-C, or runs the simulator from the same RubyMan. So we're covered on that side. But what happens if you like designing screens using GOB? RubyMotion has a gem known as IB that allows you to connect the impedance in between S code and everything per code. So with that gem, you can build your own screens using the interface builder to build the screens, and then you connect it to a Ruby code. So we're covered on that end too. As RubyMotion is completely transparent with Objective-C, we can use more than the more than 3,000 libraries available for Objective-C, which these are known as pods, like Cocoa pods. That's the most familiar with, we're the most famous one, and to that you can add the more than 500 gems explicitly developed for RubyMotion and distributed through Ruby Gems, as you should know. On testing, RubyMotion has fine-tuned it. Objective-C, if you want to do T-functional, you have to use a framework known as automation. They are written in JavaScript, so you have a mixture of JavaScript and Objective-C. RubyMotion uses MacBacon. It's a minimalistic clone of RSpec. In the simulator on the device, it works as well. So on our test rules, we can send gestures and interact with the application. In this case, we see we tap a login button and it changes color as expected. Everything in the Ruby world, right? I'm going to show you some code, how this would truly work. Let me change the display.
Me desapareció 800 por 600. Bueno, esto es lo mejor que puedo hacer, me parece.
Oh, this is the best I can do for you. No better display. Can you read anything from there? That's good? Okay. So we have the motion command. The same as on Rails, we can create our application. We go motion create, hello. It creates a few files. This is the minimum number of files you must have. If I write rake, if it doesn't change directory, we don't care. I write rake. It's the default task. It runs the application on the simulator. It's compiling the only Ruby file that I have, up delete, and when it finished, it opened the iPhone application. It's just a blank screen because I haven't told it to do anything, not more than that. But I want to show you that once you finish the compiling, I don't go back to the console prompt, but I have a REPL. It's interesting. And this is where you spend a lot of time when working with RubyMotion. It's connected to the object environment, the same as with the simulator. Let me show you now how this is used. Then, if you create something like the string hello RubyConf, I ask for the class, it's a string. If I ask for ancestors, it says here that the first in line, it says NS mutable string after all the native classes and the ones that Ruby adds by default. Let's make it more interesting. A small project that I have already put together. This class is the access point of that the OS has with our application. It's a common Ruby class defining a method using the rake parameters. The method is split into two. I create a UI window. It's a native class of the Objective-C framework, and I'm using it without any complexity. The Objective-C classes are different in the way they start. They have the alloc, and then the initialization is different, and the syntactic sugar can be changed to alloc, init, or new, but I like to maintain the difference between Objective-C and what I create on Ruby. So I have created here a UI window. I have a view controller on it, and this view controller is a Ruby class coming from the Objective-C framework known as YU controller. Then I define some methods. These are a mix of methods proper to the library or of Ruby and methods that belong to the framework like viewDid, layout, subviews. There's a gem known as motion kit that separates CSS from HTML and the creation from that is the aesthetical view window from whatever lies behind it. So here we create the layout of the view we're going to see later. Specific properties of each control. Here you have another gem, the sugar cube. Like if you have active support in Rails world, here you have sugar cube with many useful things like turning colors, taking an image from a file. Another interesting thing, I said that classes were open. Here you open the class YView. It's the class from which you inherit all other classes, and I'm adding methods to make the code more handy, prettier, like alias method I'm using too. Let me show you what this application does.
Hubiera arrancado la aplicación de cero.
If I had started with the application, it would take long. I'm sorry, resolution's not working, so let me change the simulator.
Si yo tuviera que compilar todo esto desde
If I had to compile all this from scratch, in addition to the classes I created, it would add all the classes that are in the library. So 40 files to compile. It would take an interesting amount of time. Fortunately, it's smart enough to detect that it only has to compile those things that had changed, and what didn't change is not compiled again. So we run rake and we have the simulator that works pretty well. Fortunately, it's quite faithful to what happens in the device. And if we ask Moz, what's the matter? It says, it's fine, I've sent an email, rest assured. In our REPL, thanks to one of the sugar cube gems, we have the tree command. You see the hierarchy of views on the simulator. So you interact with the views. I take one, we change the background color. I changed the background color quickly. This is important. When you have fine aesthetical details, it works very well. So you can take, for instance, if you think that Moz is too high in the image, you can bring it down. Let's bring him down, make him taller, and so on. It helps to adjust visual details. It's a good tool for that. Now, going back to my presentation, just a comment, because talking about Android would take a completely different presentation. RubyMotion now supports as well Android app development. It works like Objective-C. It's an beta status still, so if you have a RubyMotion license, you can do your motion update, download the beta, and start developing Android apps. The structure is quite similar to Objective-C, but in this case, instead of implementing the runtimes on Objective-C class, Ruby classes are applied over J and I. The codes interact transparently, you use the jars that you already know, and so on. And finally, the result provided by the tool is the AP card that you upload to the App Store. For Android, it's interesting. You should check it out. It's worth it. And that's all on my behalf. I hope you've enjoyed it. Thank you.